Hello and welcome to my channel. So in our today's video, we will learn how to make a two-way distant messaging system using LoRa modules. So to understand this project in a better way, we will go through these following topics. That is, we will start with working of the project and then understanding the working model using blocks. Then we will understand the connections diagram. And finally, we will go through the coding part for the controllers. Now let's start off with the working of this two-way messaging system using LoRa modules. So I'm using a pair of LoRa modules, that is RA02 and RA02. So RA02, the first module that is at the top, is being controlled from this Node MCU microcontroller, whereas this bottom one module is being controlled using Arduino Uno R4 Wi-Fi module. So let's consider that the top one is the setup one for user 1 and the bottom is for user 2. So these two setups are being placed with 1 kilometer at a distance so that the two users can convey their messages with a free of cost using mobile phones. So how will the user connect with a mobile phone using these microcontrollers is that these two microcontrollers are Wi-Fi enabled, so they can also be converted into a web server. So using two different routers at two different places, one of the microcontrollers connected as a web server to the router, and the same happens to this R4 Wi-Fi. So while both becomes web server, you can automatically connect to that Wi-Fi network using two different mobile phones, and you can start messaging using the browser using the web server IP address. So let's see how it is being done. So let me turn on both the microcontrollers using the micro USB and USB 3C cable. I have turned on the Node MCU. Now the R4 Wi-Fi. Right. So for the notification, I have used this 0.96 inch OLED display for Node MCU and a push button to view the IP address. Whereas here, for this module, I did not use this display because already we have a OLED display here, so I can use it for knowing the IP address and notification. And for sound notification, I'm using buzzer for either side. So this is the buzzer for R4 Wi-Fi and this is for the Node MCU. And I have added two buttons here, one for the bottom setup and another for the top LoRa setup over here. Right, so let me connect the buzzer. And one more thing, I'm using sound as a notification as well as a display notification for this project for sending and receiving on either side. So while we are programming for the Node MCU, see that the buzzer is not connected because while I tried the same with the buzzer, it didn't work properly. So once you do the connections as well as programming the Node MCU, finally you connect the buzzer. Okay, so let me give the power supply for each of the controllers, that is Node MCU and R4 Wi-Fi. Right, so at the top it started showing me connecting for the Node MCU. Right, so it says that connected, press button for IP. So which button? So here is the button. So I can press this button for showing the IP. Now the IP shows here is 192.168.1.7. Right. So this is the IP address for Node MCU. You can connect this you can connect the Node MCU and R4 Wi-Fi to different routers for checking. Right, so now let me press the second button for knowing the IP address for this web server from R4 Wi-Fi. So it shows 192.168.1.30. Okay, what I will do is I will use two mobiles from either side. So for this mobile is for connecting to the web server of Node MCU, and this mobile is for connecting to the web server of the R4 Wi-Fi module. Right. Okay, now let me turn on the mobile phones. And before that, let me connect the buzzer now for the Node MCU. Right, on the web browser, I have typed 192.168.1.7 for the LoRa module that is controlled by the Node MCU web server. Okay, now so here I have typed 192.168.1.13 for the R4 Wi-Fi web server. Let me place it like this a little. Right, so now let's start sending the message. Let's start sending the message from our R4 Wi-Fi module and receive it towards the right side, that is the Node MCU. Okay, let me type. So once I send the message, the message should be visible at the bottom. I'll just type hello bro. Are you awake? Okay, so once I sent, we got the message instantly at the receiving side, at the LoRa side, as well as I've got a notification bell symbol on the Node MCU. Now if I want to turn off the notification, I can just press the button over here, so it will hide the notification. Now the receiver needs to reply for this message, so let's send a reply. Okay, so okay bro, I am awake, so let us meet. So let me send this. Okay, so once I sent it, I got a notification here, as well as I got an instant reply over here. So now we got an understanding that how we are able to communicate with these two LoRa modules using these two controllers as a two-way messaging system. Right, so this is a working blocks model for our two-way distant messaging system setup. I have differentiated into two parts. Towards the left block, I have made the block for the user 1, and towards the right, the user 2 block is made. Okay, let me explain you how each of the blocks work. So in the setup one of the user 1, the user has a router with him and a mobile phone that is Wi-Fi enabled, and the Node MCU web server is placed near the router And finally, this node MCU is connected to the LoRa module, that is RA02, using which the user will be able to transmit and receive the messages. Right. So this is for the setup one. So here the node MCU web server gives an IP address to connect to it, so that the node MCU web server is connected to the router, so that the mobile phone also gets connected to the router. So using the web server IP address, the user will be able to access the web page of the web server, using which he will be able to convey the message and receive the message. Same thing happens for user 2 also. Here, the only difference is that the controller that we use here is Arduino Uno R4 Wi-Fi web server. So the two-way communication happens between these two setups is through this RA02 LoRa modules that is placed at a distance. Right, so this is the connections diagram for both. So I have added a push button and a buzzer for each of these setups, so that using push button, the user will be able to view the IP address and to turn off the notification. And the buzzer is for getting the notification sound. Here, towards the right side for the node MCU, as we don't have the display, we use a 0.96-inch, that is SST1306 I2C enabled display in order to view the IP address. So that's it, the connections diagram. So the program that we see here is for the node MCU of our project. So as we saw in our working of this project, we understood that this node MCU controls the LoRa module, as well as it acts as a web server, and also it displays the IP address and the notification on the OLED display. So in order to achieve that for the node MCU, we need to include these three libraries here. That is, to enable the web server and to enable the LoRa communication and for the OLED display. And these are the definitions for the LoRa pins and for the OLED display. And as we are using the buzzer for getting the notification as a sound, we will define the buzzer pin also. And I'm making a bool variable, and I'm gonna change it to false and true, so that I can display the IP address as well as I can turn off the notification. So the code will be explained below. And here is a set of lines, that is the hex code. This hex code is for making a notification icon on the OLED display. And this is the place where we will define our network SSID and password of our local router. And here is the character array inside which I'll be defining how the web page will look. So this web page will start with the doc.html type, and then inside the head I'll be defining the style, and inside the body I'll be displaying the visible features. So inside this body, you need to note down these two important things here. That is the input type text, that is inside which the user will be typing the message, and once he types, he will be clicking this button in order to send the message. So this send message will trigger this function. So here I have defined what should happen inside the function. So it gets the value. After that, it uses this function uses XML HTTP request to get the value to the web server and send it through the LoRa. So this transmit will immediately call the function. Let me show you that function. So here is that. So inside the setup I have defined, this transmit should immediately call this function, that is handle transmit. So inside the handle transmit, I've defined the function that get the message as a server string, server argument, and then attach it to the message variable and send the message through the LoRa using LoRa.print, giving a space and sending a message, and end the packet. So begin and end the packet makes the LoRa to send and close the instance. Okay, now next. So now we have understood how the message is sent. Now we will see how the receiving part works. Below the sending, we have the receiving part. That is, here we have the span ID LoRa data, inside which we will be changing this weighting, and we will be updating the newly received message. So let's see how that works. So below this send message, we have another function called update data function that will be triggered for every 2 seconds. So this function will again call XML HTTP request.open using get method. We are calling this read LoRa data. So this read LoRa will in turn trigger this function, that is handle LoRa read. So that's not a function, that is a string. So it will return the string to that function. So here is the function, that is handle LoRa read, that will update this last received text to the update method, update function. So let's see this. So this is the place where we will update the last received text. So inside the void loop, which happens repeatedly, inside which I check if the packet size, if so, if the LoRa receives data packet, then this will become true. So if it becomes true, then the last received text string variable will be made empty, and then this last received text will be updated with a new received value using LoRa.read. And finally, we send it back to the function. And also it will trigger the display notification icon and make notification sound, which I have defined separately. Here is the display notification icon, and then make notification sound. So here we have the program for our R4 Wi-Fi module of our two-way messaging system. So once we understand how the program works for NodeMCU, then the program for Wi-Fi, R4 Wi-Fi will be very easy to understand. So here, the only difference is that the library files, as well as a few lines of code that we will be seeing below. So here for enabling the Wi-Fi, we will be using Wi-Fi s3.h library. And these lines are for the Arduino graphics to display the IP address. And coming down, so we use Wi-Fi client class to create, and we use it to create an object for client, and using this client.println, we display each and every lines on the user web page. So let's go down and see the important lines here. So inside the body, input and so these are the lines that we need to concentrate. So that is to type the message and send it. So for typing the message, we will be using this input type box inside which the user will be able to type the message. And after the user types the message, he will be clicking the send button. So this send button will trigger this send function. And coming down to, so that is for the sending. And for receiving, we have defined a div inside which I have defined the LoRa text ID, where I will get this ID and I will update the incoming text. So let's see the two functions here. So this send function is over here. This send function will get the value from the URL and it will immediately call this function over here. That is if request index of URL get method and message, then we define a string that is the message, and then we send the message on the LoRa. So this is how we send it. So for receiving, this get data will be triggered over here for every 1 second. This get data will get the current string of text from the LoRa incoming packet. Over here, we update it instantly when the packet is received. So this is how the incoming works. I hope we have cleared the programming part. So where can we use this two-way messaging system? So this setup can be used for sending free of cost messages, and during network failures or floods or any natural calamities, we can use this free messaging system without interruption. Next, to convey a message during emergency, like if someone loses their mobile phone and they can communicate with their loved ones using a different mobile, using this by just enabling the Wi-Fi and connecting to the web server. Right. So these are the advantages of using this two-way messaging system. So along with this video, I will include the project files and also the connections diagram and this presentation, what we have discussed right now. So I hope you enjoyed this video and thank you so much. If you have any queries, you just type it as a comment. And let's meet again with another project. Have a good day.